In this video, we are going to solve the test which is of 20 marks on current electricity. This is the syllabus of class 10 ICSE and the paper is on YouTube Shorts. The link will be in the description box. So you click on that link so that you'll be able to see the paper. Pause that video, solve the paper and check the answers with this one. Okay? So we are coming to question 1A. The question says, state the relation between internal resistance, terminal voltage and electromotive force. So your relation is E minus V is equal to IR, and we have to write where E is the EMF. So we will write electromotive force, V is the terminal voltage, and small r is the internal resistance, and I is the current in the circuit. So this was our question 1A, first part. Your second part asks us, state the combination of resistors in which the potential difference between each resistor remains the same. So PD remains the same when the resistances are in parallel. Combination of resistances. Underline the word parallel. We come to the third part. State the combination of resistors in which the potential difference between the individual resistors depends upon the value of its resistance. So that will be the series combination of resistances. Because in series, when we have the resistors connected like this, the current through each resistance is the same. So if my resistors are R1, R2 and R3, the potential difference across R1 will depend upon R1. V1 will be equal to IR1. If I have here another PD, that is V2, will be equal to IR2. So you will see the potential difference depends upon the value of the resistance. So this is a series combination of resistors. Now we come to question 1B. In question 1B, we have a diagram given. So this is a diagram of question 1B, and this diagram is for 3 marks. We have the cell with the EMF 10.5 volt and internal resistance 0.5 ohm. And then we have the key, the ammeter, and then this 2 ohm resistor connected to this 1.5 ohm and 3 ohm resistors. Alright, so we are asked find the current in the circuit. For that we will have to find the total resistance in the circuit. So we will have the first part over here. We will say that 1.5 ohm and 3 ohm are in parallel. Therefore, 1 upon Rp is equal to 1 upon 1.5 plus 1 upon 3, and we will have our LCM coming to 3, so you will have 2 plus 1 here, that is 3 upon 3, and therefore we will have Rp will be equal to 1 ohm. This will be 1 and Rp will be reciprocal of this one, that is 1 ohm. So the combination of this is going to be your 1 ohm. The current in the circuit is going to be E upon R plus R. Now R is the external resistance and this small r is the internal resistance. EMF is 10.5 volt and the external resistance is Rp plus 2 ohm and plus small r. So this is the external resistance plus this one is the internal resistance, that is this one over here. So that will give you 10.5 volt upon 1 plus 2 plus 0.5. These many ohms. So that will be 10.5 upon 3.5, which will be 3 ampere. So this will be your current in the circuit. We will say that is I in circuit. And that becomes our answer 1. For the second part, we have to find the current in 3 ohm resistor. Now the current in the circuit, that is 3 ampere, is going to go into two branches now, and we want to know this one. So if you call this as R1 and we call this resistance as R2, then let the current in R1 be I1 and the current in this become I2. So in order to find I1 and I2, we will first need the PD across the parallel circuit is going to be equal to Vp, which is going to be IRP. The current in the circuit is 3 ampere, which we already got over here, and multiplied by Rp, which is 1 ohm here. So that becomes our 3 volt. So therefore I2, which is the current in 3 ohm resistor, is going to be equal to Vp upon R2, because V is equal to IR. So I becomes equal to V upon R. Okay. So your Vp is the PD across parallel circuit, which we found here as 3 volt, and R2 is this 3 ohm, and that will give us 3 ones and 3 ones here. So that is 1 ampere. Okay, so that is your answer 2. Now let us look at our marks. This one is of a 1 mark. This is of 1 mark, this is of 1 mark, and here this question is of 3 marks. So 3 marks, you will first get 1 mark for finding Rp, then 1 mark for finding this, and then 1 mark for finding this. So basically we have now finished with 6 marks. Let us come to question number 1C. First part, you are given 3 10 ohm resistors. So we have 10 ohm, 10 ohm and 10 ohm, and we have to connect them in such a way to obtain equivalent resistance of 15 ohms. They say draw the diagram and show the working to support your answer. So if we have 15, so 15, our thinking step, it is 10 plus 5. So we will have to have one 10 ohm resistor connected with the combination of the other two, which should give us 5. So if I'm going to decrease the resistance, these two resistors cannot be in series. So let us connect them in parallel like so. And this is your 10 ohm and this is our 10 ohm. Okay. So we will have Rp will be equal to R upon 2, which is 10 upon 2, which is equal to 5 ohm. So if I use R upon N formula, then I can get this, or you can say 1 upon Rp is equal to 1 upon 10 plus 1 upon 10, which is equal to 2 upon 10, which is 1 upon 5. Therefore, Rp will be equal to 5 ohm. So either do this way or this way, not a problem, but Rp is 5. And then you will see that this is your Rp, which is connected in series with this 10 ohm. So you will say therefore total resistance is equal to 10 ohm plus Rp, and which is 10 ohm plus 5 ohm. That will give us 15 ohm, and that is how we show it in our calculations. Now this one is a 2 mark question. So this diagram will give us 1 mark, and to show this, all this is going to be for 1 mark. Okay, now we come to C, second part. Calculate the equivalent resistance between A and B. For a question like this, always draw the rough diagram first, and then you will say that 24 ohm and 24 ohm are in parallel. Therefore, 1 upon Rp will be equal to 1 upon 24 plus 1 upon 24, which will be 2 upon 24, which is 1 upon 12. So therefore your Rp is equal to 12 ohm. Now this is your Rp, which is 12 ohm, and that is connected with this 2 ohm in series. So 2 ohm and Rp are in series. Therefore, equivalent resistance between A and B is equal to 2 ohm plus Rp, which is 2 plus 12, which is equal to 14 ohm. And that is our answer. Let us look at the marking scheme. This is for 2 marks. So finding Rp is 1 mark and getting this 14 ohm with all these statements. If the statements are missing, remember the marks will be missing. In any one of these questions, if any of the statements are missing, remember a mark can be cut. So make sure that you're writing these basic statements. Don't just write numbers, don't just write this calculation and this calculation. Make sure that you're writing this and this. It doesn't take you too long to write these things. So this finishes our question 1. Question 2a says state Ohm's law. Now Ohm's law you have to know by heart. Take it from any textbook. Okay, and that will be for your 1 mark. The second part says state the limitation of this law. So right over there, limitation of Ohm's law. We will say that the physical conditions like temperature must remain constant. Underline temperature and remain constant. The third one says write the expression for the Ohm's law, and the expression for Ohm's law is going to be written, we will say V is equal to IR. But this is not enough. You have to write over here where V is the potential difference, I is the current in the circuit, and R is the resistance. So we will have Ohm's law for 1 mark, writing this temperature constant, and here for V equal to IR, you can put this in a box like this and write this. For writing this along with this is going to be your 1 mark. If you only write this, you have a chance of losing your marks because you have not specified. Either you can say potential difference is equal to current into resistance, or you write this and this. Only this over here will not give you your marks. Okay. Question 2b says, in the following diagram, state the graph which represents the combination of resistors in which the equivalent resistance is lesser than the least, and justify your answer. So we will say lesser than the least resistance is in parallel combination. So you have to understand whether A is showing parallel combination or B is showing parallel combination, which means you have to find out which one is having the lesser resistance. Now the simple diagram will be where I will draw a line parallel to y-axis. For the given PD, I will have here, this one is going to be current in B, and this is going to be the current in A. So I will say for given PD, I in A is greater than I in B. Okay, so we shall say that the resistance in A is less than resistance in B. And here we will say since the resistance is inversely proportional to the current. So if A has less resistance than B, A represents combination of parallel combination, underline parallel combination of resistance. We come to question number 2C. The first one, state which of EMF and terminal voltage is greater when a cell is connected in a closed circuit. Now in a closed circuit, we will have EMF is greater than terminal voltage. Second part, state which of EMF and terminal voltage is greater when a cell is being charged. When the cell is charged, your terminal voltage is greater than EMF. Third one, state which of EMF and terminal voltage is the potential difference of the cell when connected in an open circuit. Now, in an open circuit, your EMF becomes the potential difference. So here it will be EMF as the answer. And the fourth one is state which combination of resistors will have the same value of electric current through each individual resistor, and that is going to be in series combination. In series combination, remember, the current remains the same in each resistance, but the PD is changing. So this finishes the written work. Now let us look at our marks. The marks will be for this. This was your 2-mark question. Question 2B was a 3-mark question. So we have to understand lesser than the least means it is your parallel combination. And then for the given PD, the current is more, and the current is more in A and resistance is less in A. So that will be our first mark, and therefore we will say that A has less resistance, and therefore A represents parallel combination. This point over here and this point over here, these ones are connected. So if you've written this as well as this, then give yourself 1 mark. So this is going to give you 3 marks for your B. And here for C, this is 1 mark each. These questions are like objective questions. For this EMF, you could also write as electromotive force, because many a time your teachers will not like it if you write a shortcut if it is just 1 word. So if you are just writing EMF here, which is the abbreviation of electromotive force, you may just lose that mark. So it's better to write the full form of this. So that finishes our 20 on 20 marks in this test. So write in the comment box how much did you get. Okay, so in the meantime, study well for your examinations, which is in the month of March. Focus well, work well, stay safe, stay healthy. Bye.